All right, let's get right into it. When you first look at AWS Route 53's routing policies, it can feel, well, a little overwhelming, right? So today, we're going to clear all that up. We're going to break down three of the most powerful and sometimes confusing options: geolocation, geoproximity, and latency.
Okay, let's kick things off with a pretty simple scenario. Imagine you have a user sitting in London, and you've got servers running in Paris and also in New York. So here's the deal. Where do you send that user? Paris? New York? It seems so simple on the surface, but the answer, well, it's not what you think. And that's because, honestly, it's kind of a trick question. There is no single right answer here. It all comes down to what you're trying to do. What's your goal? Is it all about legal stuff and compliance? Or are you maybe trying to balance out the load on your servers? Or is it just about pure raw speed? Each one of those goals leads you down a completely different path.
So let's start with our first policy, geolocation. And the best way to think about this one? Picture a really strict border guard. Its whole job is to enforce rules based on really clear, really defined boundaries. So officially, what it does is route your traffic based on where your users are coming from, geographically. Route 53 figures this out from their IP address. Now, this is super important. This is not about how close they are physically. It's all about political lines on a map, continents, countries, even specific states in the US. So if a user is in France, you can literally set a rule that says, nope, you have to go to our server in France, period. Okay, so when would you actually use this? Well, it's all about enforcing rules. Number one is compliance. Think about GDPR. You absolutely have to keep European user data inside Europe. Geolocation is how you do that. Then there's content localization. Maybe you want to show prices in euros to anyone in Europe and US dollars to anyone in America. Easy. And the big one, of course, is licensing. Making sure that TV show you only have the rights for in the UK can only be watched by people actually in the UK. Okay, but here's a really important thing you've got to know. A little catch. What happens if someone pops up from a location that doesn't match any of your rules? You don't want them to just get an error, right? So Route 53 makes you set up what's called a default record. Just think of it like a safety net. It catches anyone who doesn't fit a specific rule and sends them somewhere you've decided on ahead of time. All right, on to policy number 2. Geoproximity. So if geolocation was our strict border guard, geoproximity is more like a flexible traffic balancer. It's way less about hard and fast rules and a lot more about gently nudging your traffic around. So how does it work? Geoproximity looks at the actual physical distance, like as the crow flies, between your user and your AWS resources. And that's the key difference right there. We've totally shifted from political boundaries to pure, simple physical distance. Okay, everybody's studying for a certification. Listen up. If there is one thing you remember about geoproximity, let it be this. The most important concept, bar none, is something called the bias factor. This is where you get to take control. So what is this bias? It's just a number you can set, anywhere from -99 to +99, and it lets you basically cheat. You can artificially make a region's geographic reach bigger or smaller. If you give a region a positive bias, you're telling Route 53, hey, make this region look closer to more people. It'll start pulling in traffic from further and further away. And a negative bias, it does the exact opposite. It shrinks that region's footprint, pushing traffic way to your other resources. This is absolutely perfect for when, say, one of your data centers is getting slammed and you need to shift some of that load somewhere else. And hey, another huge tip for anyone taking an exam. See, with most routing policies, you just set them up with standard records. Not this one. For geoproximity, you have to use the Route 53 Traffic Flow Visual Editor. It's a requirement. So if you see traffic flow mentioned in a question, a little light bulb should go off in your head pointing straight to geoproximity. All right, last but not least, we have latency-based routing. And this one is an absolute purist. It doesn't care about your borders. It doesn't care about physical miles. It has one single obsession: speed. What latency routing does is simple. It sends every user to whichever AWS region can give them the fastest possible response time. See, AWS is constantly keeping tabs on network performance all over the internet, measuring how fast it is to get to its regions. And it uses all that real-time data to make the best choice for every single request. And here's how it really works. It's all about the lowest round-trip time, measured in milliseconds. An internet request isn't a straight line on a map, right? It bounces all over the place through different routers and cables. This policy is smart enough to find the absolute fastest electronic path, not just the shortest. And this leads us to the number one mistake people make when thinking about this. You might think that for a user in London, the Paris server is the obvious choice because it's geographically closer than, say, a server in Dublin. But what if the network path to Dublin is less crowded? What if it's using faster fiber optic cables? In that case, Dublin could actually be faster. It could have lower latency. Latency routing knows this, and it'll send that London user to Dublin every time to get that better performance. Okay, so we've met our three contenders, the border guard, the traffic balancer, and our need for speed purist. So now let's put them all head-to-head in a final showdown. This is where it's all going to click into place.
All right, let's just run through this table. It really makes it clear. First up, logic. Geolocation, that's all about political boundaries, country, continent. Geoproximity, that's pure physical distance. And latency, that's just network speed in milliseconds. Next, the primary goal. For geolocation, it's compliance and localization. For geoproximity, it's all about shifting traffic around. And for latency, it's one thing, performance. Now look at the control tool. Notice how geoproximity is the odd one out here. It's the only one that requires Route 53 traffic flow. And finally, adjustment. How much control do you have? With latency, you have none. It's all automatic. But with geoproximity, you have that incredibly powerful bias value to fine-tune everything. Okay, let's wrap this up with the most important part, your certification cheat sheet. If you're cramming for an exam, these are the mental shortcuts that will let you instantly nail these scenario questions. Okay, tip number 1. When you're reading the question, look for the key words. If you see words like compliance, data residency, or especially legal stuff like GDPR or local laws, boom, the answer is geolocation. That's our border guard enforcing the rules every time. All right, tip number 2. This one is the easiest giveaway of them all. If you're reading a question and you see the word bias, just stop right there. The answer is geoproximity. That bias value is its unique superpower. It's a dead giveaway. And finally, tip number 3. This one's all about the user experience. So if the question is all about giving users the best experience or the lowest latency or the fastest possible response time, you know the answer. It's latency. That's our speed-obsessed policy. It's all about performance. So there you go. It's not so complicated after all, right? You've got 3 amazing tools for 3 very different jobs. You have the border guard for your rules and compliance, the traffic balancer for when you need to shift things around, and the speed demon when all that matters is performance. So now you know the tools. The only question is, which architectural challenge are you going to solve first?